So before the last video ended, I figured out what x was for 3, and we already did 1 and 2, but someone interrupted me, Trevor, so I'm just going to finish it up. So we found out that for number 3, that x is equal to 11, and we found this by setting the equations equal to each other. So now what we need to do is figure out the value of y. So how we do that is we substitute x for 11 back into the equation. So you could do it to either equation, it doesn't matter which one. So 3 times 11 minus 30, so it's 33 minus 30, so 3 equals y. But we should check it for the other one just to make sure we did x, or x is actually correct. So then y equals x plus, or negative x plus 14. So negative 11 plus 14 does equal 3. So we know that x equals 11 is right, and y equals 3. Okay. Aiden?
Okay, so number 4. Alright, I'm gonna bring this over here because this involves fractions. So to start, they're not in y slope intercept form yet. So we have x plus 6y equals 15, and I'm gonna subtract x from both sides. So you get 6y equals negative x plus 15. And I'm going to divide everything by 6. So you get y equals negative 16x plus 15, 6. Okay, so then the other equation is negative x plus 4y equals 5. And then I'm going to add x. So then we have 4y equals x plus 5. And you divide everything by 4. So you get y equals 1/4 x plus 5/4. Okay, so I'm going to write the equations over here. So you have y equals 1/4 x plus 5/4, and y equals negative 16x plus 15, 6. Okay. Alright, then we need to set the equations equal to each other. So you have negative 16x plus 15, 6 equals negative 1. Oh my gosh, there's so much. Oh. Okay, so then that equals negative 1/4. Oh, it's not negative. It's just 1/4 x plus 5/4. And so first I'm just going to get a common denominator. So I'm going to do 24ths because it just is easier for me. So you have negative 4 24ths x plus 60 24ths equals 6 24ths x plus 30 24ths. So I'm going to subtract 30 24ths from both sides, and then you get negative 4 24ths plus 24th x plus 30 24ths equals 6 24ths x. And you add 4 24ths to both sides, so you get 30 24ths equals 10 24ths x. Okay, so then I'm going to divide everything by 10 24ths, and I'm going to do that, I don't know where I'm going to do that. I'll do it right here. So I know that when you are dividing by a fraction, you can also multiply by the reciprocal. So we have 30 here. And I change the color. So you have 30 24ths times 24 over 10, because that's the reciprocal of 10 24ths, So 24 and 24 cancel out, and the 0 cancel out. So then you just end up with 3 over 1, or 3. So we know that x equals 3. Okay, so then, okay, so now that we have x equals 3, we can substitute it into the equation. So we have 3 plus 6y equals 15. Then if you subtract 3 from both sides, you get 6y equals 12, and you get y equals 2. So to make sure that works for the other equation, we're going to do negative x plus 4 times 2 equals 5. So negative x plus 8 equals 5. Then you add x to both sides, so then you have 8 equals 5 plus x, and then subtract 5, so then you have 3 equals x. And so it works, so you know that the coordinate pair is 3, 2. Okay.
Okay, for number 5, where is it? There it is. Okay, so this equation is not, these equations are not in y equals mx plus b format, so that's what we need to do first. Okay, so x minus y equals negative 5. So what you can do, change the sign, subtract x. So we know negative x equals negative 5 minus x. Multiply everything by negative 1. Y equals 5 plus x, or x plus 5. So this in y equals mx plus b format would be y. That's really close together. I'm just gonna I don't know why I did that. This is going downhill. Okay, so then we know this could also just be y equals x plus 5. Okay, and so for the next equation is negative 2x plus 2y equals 10. So we could subtract negative 2x, or it's the same as adding. So you get 2y equals 2x plus 10, because subtracting a negative is the same as adding a positive. Divide everything by 2, and you'd get y equals x plus 5. And then you know that you see that these two equations are the same. So when you set them equal to each other, there are an infinite amount of possibilities because they are the same. So there is the answer is infinite, because if you substitute anything in for x, you'd get the same answer, because you get x equals x. That's the 5. Okay.
Okay. Alright, so Alright, so 6 is not in slope-intercept form yet, so I'm going to do that. So we have x equals minus y equals negative 5. Then you subtract x from both sides, so you get negative y equals negative x minus 5. I'm going to divide everything by negative 1, so you get y equals x plus 5. And then for the second equation, you have negative 2x plus 2y equals 8. So then I'm going to add 2x to both sides, so you have 2y equals 2x plus 8. Then you divide everything by 2, and you get y equals x plus 4. So when you set these two equations equal to each other, so right here you have x plus 5 equals x plus 4. And if you were to subtract, so you know that they have the same slope, because if there's just one x, so the slope is 1 for each of them, but they have a different y-intercept. So that means that they're going to be parallel, but not the same line, and we can tell that they have that they don't intersect anywhere, because if you subtract x from both sides, then you get 5 equals 4, and that is not true. So we can tell that for 6, there are no solutions. Okay, so the next problem is about Ming and Ian Mi, and they discuss how to solve the system. So I'm going to talk about Ming's way, which is x equals ny plus c, and I think that that is still correct. So first we're going to start by solving that, and this is basically just solving for y instead of x. So we're going to put it into this form. So we have x plus y equals 3. And in this form, we're going to isolate the x, so I'm going to subtract y. So we have x equals negative y plus 3 for the first equation. And then for the second equation, we have x minus y equals negative 5. And we want to isolate x again, so we're going to add y to both sides. So we have x equals y minus 5. Okay, so then once we have these two equations, we can set them equal to each other. So we have negative y plus 3 equals y minus 5. And then if we're going to, first we're going to add y to both sides. So we get 3 equals 2y minus 5. Then if you add 5 to both sides, you get 8 equals 2y, or y equals 4. Okay, so then you can substitute y into the initial equation. So you have x plus 4 equals 3. And then if you subtract 4 from both sides, you get x equals negative 1. So that's what we got for the first problem. And we're going to see if we get the same thing using EM's way. So we got negative 1 comma 4. So using EM's way, it's just slope-intercept form. So we have x plus y equals 3. And so we want to isolate the y in this one, so we subtract x from both sides. So then we have y equals 3 minus, oh, that was a bad minus. 3 minus x. And then for the other equation, we have x minus y equals negative 5. And we're going to isolate isolate y, so we subtract x. So we have negative y equals negative x minus 5. Then we can divide everything by negative 1 and get y equals x plus 5. So now we can set these equations equal to each other. So we have 3 minus x equals x plus 5. And once we solve that, we're going to add x. So we have 3 equals 2x plus 5. And then if we subtract 5, we get negative 2 equals 2x. And then divide everything by 2, and we get x equals negative 1, which is what we found for the other one. So now we just need to substitute x into the equation to make sure that it works so that we get 4 as y. So we're going to have negative 1 plus y equals 3. And if you add 1 to both sides, you get y equals 4. And so we get negative 1 comma 4 using both methods. So that means that Yeonmi and Ming were both correct.